Moving to the next presenter, that's Professor Yan Xiao from Zhejiang University in Haining, China. Like Professor Li before, Professor Xiao is also a fellow of the International Academy of Wood Science. And today his presentation will be about cross-laminated bamboo and timber, CLBT. Professor Xiao, the floor is yours.
Well, my presentation is on cross-laminated bamboo and the timber, or CLBT. I would like to thank my funding agencies, my colleagues, and the students. First of all, a brief introduction about the background. As we all know that the bamboos are very well available throughout the world, particularly in developing countries. So these are the bamboo distributions, forest distributions in China. However, the bamboo are not fully utilized. For example, this is a photo taken from the bamboo forest, and with improper management, less cultivation, the degradation of the bamboo forest is quite severe. The quality is degrading. The interest in the construction industry with bamboo has been growing for about 10 to 15 years. The reason is because of the expectation about the bamboo as the green material, particularly because they grow fast and can recycle quickly. And this is a research we conducted 10 years ago that to look at the carbon footprint of bamboo without a comparison with other materials. So basically, the engineered bamboo are like other biomass wood materials. They are as material, they are all carbon negative materials. So we have been working on the engineered bamboo and for last 17 years. So we developed a product called GlueBam. Now it's not a product. GlueBam has become a kind of general terminology, basically laminated bamboo. The process of producing bamboo GlueBam is similar to glulam. However, we need to use the pre-processed laminated bamboo board like this. The two types of the laminated bamboo boards we are using. One we call it the thin strip board. The other one is thick strip boards, and the price of a thick strip is much higher than the thin strip. The thin strip board was originally used as a formwork for concrete, and the thick layer or thick strips were used for bamboo floorings because each strip are fairly accurate. Typically for this case, it's unidirectionally distributed, and this case bidirectional. Okay, so in last 70 years, we have been conducting quite a lot of material testing and the structural components testing and some of the system testing. This is our most recently published work with the ASC Journal of Materials. It's a torsion behavior of a GlueBam in comparison with SPF. Some of the bamboo fiber bundle test and the fungal attack test. So we believe GlueBam can be used as the railings for transportation field to prevent car collisions or to resist car collisions. So we conducted the high strain rate testing and also impact testing with pendulum impactors. Some of the shake tape test and the fire test for full-scale room behavior. We also look at the combination of GlueBam and the steel. GlueBam with the light gauge steel as for shear walls. GlueBam with concrete slabs for hybrid composite beams. Shake tape testing, And our previous work in last 17 years have been summarized in my recent book on engineered bamboo structures, published by Taylor and Francis. The development of CLBT is my main topic today. So first one, very briefly, the CLT is introduced here, described here. It was, as we all know, it was originally developed in the 1980s in Germany, and then spread now in the whole, almost everywhere in the world. Become a very promising product. Some of the testing conducted in the E-Defense Shake Table, and some of the tests in Colorado, I believe. So why we could, so this is the examples of some of the buildings, examples of timber buildings that become tall and high or super sweepers. So they currently, in the world structural engineering, the major challenge is to use timber for high-rise or tall buildings. So our motivations for developing CLBT we are inspired by the research and the practice of and the success of CLT in Europe and elsewhere, like in North America. And we were trying to use bamboo because they are very well available, and also our research experience on glue band. We would like to combine the usage of bamboo with the fast-growing timber species that very well available recently now in China. And we would like to create a composites. As we all know that when you create a composites, it is fairly likely that we can combine the merits of maybe doubling or even more merits that can be obtained. So we would like to combine bamboo resources and currently very well available fast-growing wood species in China, so we can eventually cut down the import for the Chinese industry, because China now is the largest timber import in the world. So this is the concept of the glue band, and we put the CLT inside, but then we put the glue band in the surface, two type of that. And certainly if necessary, or if the architect prefer, we can put the timber outside and glue band inside. These are our final products, slabs, and this is a 6 meter long and 1.2 meter wide CLBT planks. For this case, if we use a thick strip glue band as the surfaces, so basically we can build the slabs with the bamboo floorings at one time, so we reduce the we don't need to do the flooring anymore. So the CLBT can serve as both structure and also as the interior. Some of the test results we conducted and also published the results in 2021 in ASC Journal of Materials. No, I think it's the Journal of Structures, probably. Panel test for bending, and in this test program we have 4 parameters. We combined we used the 2 type of glue band and the 2 type of wood species at the inner layers. The SPF imported from Canada and also the poplar trees in local fast-growing poplar trees. The exteriors are thin strip glue band and 6 strip glue bands. Some of the testing results are very typical elasto-brittle material behavior shown here. My colleague Dr. Lee and also conducted inner layer interfaces shear behavior. And my postdoc, Dr. Wen, developed the exactly elastic solution for CLBT beams with layered structures. And compared with the test results, and the comparison is quite reasonable. And we recently published a paper on thermal performance of comparing CLT and CLBT, both materials and also the full-scale panel tests using guarded hot box. This is the size of the specimens, panel specimens. The thickness is 180 about millimeters. Some of the details, some of the test results, and it's not drawn from to scale, and basically CLT and CLBT, they are quite similar. It shows here that the CLBT is the thermal resistance is a little bit lower than CLT, because the axis start from 2.2 up to 3.0, and this is reasonable because glue band is because the glue band specimen was a little bit thinner than CLT specimens, and also bamboo itself is a little bit denser than timber. Therefore, the resistance was smaller. So this has been proven by our previous tests on thermal behavior of glue band too. We also published a paper recently on Wood Sciences. I think it's a European journal, and about the CLBT and glue band, and also the SPF, or the acoustic behavior using the microphone impedance, 2 or 4 microphone impedance tubes. This result I will not go through. So the thermal panel tests that we conducted, the full-scale specimens, after we done with the thermal test behavior, the panels were still available. Therefore, we used them for wall panel acoustic tests. We're currently summarizing the test result. This is the human-induced excitation test for CLBT's plate or slabs, just recently completed. There are some procedures of testing. We are now currently testing the shear walls of glue band shear walls with either 1 panel or 2 panels. Recently, over the last 17 years, we have built quite a lot of structures in China and also in Africa using glue. But recently, we very lucky received a project, a real life project of public building of a 2-story with about 2,000 square meter foot areas for the building areas. Basically, it's a frame structure with braces for lateral resistance. The frames are on CLBT. The frames are on glue band frames with the longest span of 16 meters. Okay, most of the other beam span are 8.6 meters. That my students involved in the project, these are the elements just finished the lamination. We haven't fine-tuning the surfaces. Some of our homemade equipment, and these are the basically final columns with the connection details. These are beams. In this building, the floors will be built with CLBT with different lengths, but the widths are all typical 1.2 meters. The length, the glucose elements length, the longest one was 6.1 meter. However, it was placed across different, but the clear span of the CLBT is across 2 meter spans, the sub beams. Okay, so basically that will be the world, probably world's first CLBT buildings, and also the largest Gluban buildings with official approval for design and construction. For conclusion, so based on our 17 years of studies on Gluban, it is clearly shown that the bamboo can be engineered and utilized in modern and industrialized building systems. So it is quite promising to challenge tall and high-rise building and the long span structures using bamboo, just like timber. So we believe there are potential merits of combinations of rich resources of bamboo and the local wood species. So eventually we can create the cross-laminated bamboo and the timber, CLBT. Or we can call it the cross-laminated timber and the bamboo, or CLTB. With that, I would like to thank you again. This is my email. You can contact me. Thank you very much.
Okay, thank you for the presentation. Very interesting.